Next one, Cody has 3 wooden spherical balls. The radius of the middle-sized ball is twice the radius of the small ball. That allows me to say that we've got the small one, medium one, and the large one. I've labeled as small, medium, large. Since the radius of the middle is twice the radius of the small, I've got to take the small and double its radius to make it the same as the radius of the middle. And the radius of the largest is 5 centimeters larger than the radius of the smallest. So the radius of the smallest plus 5 is going to be the radius of the largest. We're being told the surface area of the largest is equal to the sum of the surface areas of the two smaller. Find the radius of the middle-sized one. We're being told that the surface area of a sphere is this formula. So what I said in words was the surface area of the large equals the surface area of the small plus the surface area of the middle size. Then I began to substitute in what I know. I know that the surface area of the large, and we're going to use 4 pi r squared. Here's my 4 pi. The radius of the large is r plus 5 squared. That'll be equal to the surface area of the small, 4 pi r squared, plus the surface area of the medium one, which is 2r squared. Expanding the brackets, r squared plus 10r plus 25, r squared, and 2r quantity squared gives me 4r squared. Before I did this line, though, I divided the entire thing by 4 pi. By dividing both sides by 4 pi, you get rid of the 4 pi's. Combine like terms, set equal to 0. Now once again, I'm looking for numbers that multiply to negative 100, but add to negative 10. That's what I put here. Why do I keep putting AB? It should be, I'm looking for the numbers AB, where A times B equals negative 100. That's the 4 times negative 25. And I'm looking for those same numbers A and B, where when I add those numbers together, I get negative 10. Since those numbers don't exist, that tells me I'm not going to have integer answers. I've got to, again, use the quadratic formula. 4 is A. Negative 10 is B, negative 25 is C. Substituting into the quadratic formula, getting to 10 plus or minus root 500 over 8 gives me one radius of 4.05 to 2 decimal places. The other radius of negative 1.55 has to be disregarded. As we cannot have a negative radius. It doesn't make sense in the real world. Using that, putting it into since we know the medium one had twice the size of the smallest one, we get 8.1 centimeters as our radius of the middle-sized ball. Yes? How did I end up with an R that wasn't squared?
Because in your quadratic, like,
Well,
standard form thing, we've got an R squared and an R. So I'm just wondering how you got that, because the R's always been squared.
Yeah, they are all squared.
Original equation.
They're all squared here. Well, since I've got R squareds, I combined my like terms and made a quadratic.
But how come that R is no longer squared?
Because when you're solving your quadratic, you're finding the value of R, not R squared.
In your third line there.
Here?
How come that 10R is not squared?
And here? Why is this 10R? Because what I started with for the large ball is R plus 5. That's the radius squared. When I expand the brackets, R plus 5 quantity squared turns into R squared plus 10R plus 25. Does that answer your question? Okay. Okay, the next one, unless there are more questions on part E, make that C. Jackson?